Hi class! Our next video is about the Ekman Spiral. I've had a couple of questions about this and just wanted to make sure we were all clear on what was going on with this. So I'm going to show you a video that's actually from your interactive videos from the My Meteorology website, and we're going to talk about the Ekman Spiral here. So remember, ocean currents are set up by the fact that wind blows over the surface of the ocean. And there's some friction between the wind and the ocean. And so the wind, the air moving over the ocean surface, is going to drag that surface of water with it. And then the next level water is going to drag the layer of water below it with it. And the next layer of water below that is going to drag that next layer of water below it. And so what we have is sort of a cascading effect from the wind dragging the water, and one layer of water dragging the next layer of water, and the next layer of water dragging the next layer of water. And basically your velocity is going to decrease as we move from the ocean surface down. But we have another effect, and that is the Coriolis effect, which of course in the northern hemisphere is dragging those ocean currents and wind currents to the right, and in the southern hemisphere to the left. So let's watch the video. So here we have the wind that's pulling this ocean current, and it's being deflected by the Coriolis effect. And as we go down in depth into the ocean, so this cube here is essentially a cube of ocean water, and the arrows are vectors showing the velocity of those ocean currents. So if we look down from the top, this square here is saying, let's look at the top view. So we're here and we're looking down in plan view. And in plan view, we can see, let me pause it here, we have the wind blowing in this direction, and then the surface is headed off to the right. We're in the northern hemisphere. The Coriolis effect is pulling it off to the right. And then as we go down in depth, we're going to go further and further and further and further to the right, but those arrows are getting shorter because the velocity is decreasing, because there's less and less effect from the wind as we go deeper into the ocean. And so the net effect of the wind blowing in this direction and the Coriolis effect pulling it in this direction is that the net Ekman transport is to the right in the northern hemisphere. So the reason that we call it the Ekman spiral is that if you traced the end of these arrows, it actually creates a shape like a spiral. So the magnitude of the velocity decreases as we go deeper, and the direction is forced more to the right with the Coriolis effect. So the net effect along a shoreline is in the northern hemisphere. If we have the wind blowing in this direction, our deflection is going to be to the right. So that's what the blue arrows are showing. So the surface water is going to be moving away from the shore. And because that water moves away from the shore, then you're going to get some deeper water is going to move back in to replace that surface water moving from the shore, and that's what we call upwelling. So we have this deep, cold, nutrient-rich water that's going to upwell at the shore as that warm surface water moves away from the shore. And then if we change the direction of the wind, now in the northern hemisphere, that surface current is going to move toward the shore, and you're going to have downwelling. Because that current moves to the shore, it's a mass balance, right? That water has to go somewhere. So if the water moves to the shore, it's got to go down, and then it's going to go away and in the deeper current. And if we switch hemispheres, let's switch hemispheres. So now, if we're in the southern hemisphere, the deflection's to the right. So the green arrow is showing the direction of the wind. The blue arrows are saying the surface water is deflecting to the left, and the purple arrows are showing the fact that now we have upwelling, because the wind is pushing the water to the north. The Coriolis effect is pulling it to the left, that surface water, and with the Ekman spiral, we have a net movement to the left at the surface, and then eventually we have to have that deep water coming up, that deep, cold, nutrient-rich water replacing that surface water, so we have upwelling. So that, in effect, is the Ekman spiral and its relationship with the hemispheres and upwelling and downwelling.